Hey there. So what we're going to do in this video is we're going to tackle the first half of section 8.2, which is multiplying polynomials. The second half will be the factoring portion that you see in the topic. So 8.1 or the previous videos were adding and subtracting, and then today we're going to talk about how what multiplying polynomials looks like. So just to kind of remind ourselves of distribution and the distributive property, we're going to go ahead and distribute or remind ourselves what it looks like to multiply a single number with something that's in parentheses, right? And the way a lot of students think of this is that this number 3 needs to multiply to both of those terms in the parentheses. So I need to multiply each of the 5x and the minus 2, I need to multiply each of those things by 3. So 5x, when I multiply by 3, will become 15x. I like to think of this as negative 2. Some people think of it as minus 2, but I like to think of it as 3 times negative 2, which is negative 6. 15x minus 6. I cannot combine those terms, so that is done. So if we do this, now if I distribute a negative number, same thing holds. Just make sure you're multiplying by the negative version of 6. So negative 6 times 4x will be negative 24x. Negative 6 times negative 1 is plus 6. Again, can't combine those terms, so we move on. Now this is kind of what we're getting into today. What happens if I want to take something like 8x and distribute that through something like 2x plus 3? Well, if I have 8x multiplied by 2x, okay, another way I can think of this is 8x is 8 times x, and 2x is 2 times x. I'm going to go ahead and multiply. I can multiply the numbers together to give me 16, but then I'm going to multiply the x's together, and we know that if you take x times another x, I can write that shorthand as x to the second power. Okay. So when we're multiplying, we will multiply the numbers together. But when it comes to variables, x times x means x to the first times x to the first. And we know I can just add those powers together to get 16x to the second power. And then for the second part, 8x times positive 3. Well, 8 times 3 is 24. And this single x that is in that's with 8 just kind of comes along for the ride. So 16x to the second plus 24x is our final simplified expression for that. So that's kind of just a quick recap of distribution. Okay, and again, to reiterate from that third example, we are going to be multiplying monomials together. We multiply the coefficients, meaning the numbers, the big numbers, the regular numbers, and we are going to add the exponents or add the powers. So if I wanted to take something like 3x and distribute it to the expression 5x squared minus 9, this would be 15x to the third power, because I have one x and that's multiplying with 2 more x's. And then 3x times minus 9 is going to be minus 27x. Both of these terms have x in them, but they are different powers. So that would be my simplified expression, 15x to the third minus 27x. Okay, same idea here. I'm now multiplying a monomial. Again, monomial means 1, with a trinomial, which means 3. Okay, so same idea. I'm going to go ahead and distribute the monomial across all 3 of these terms. So I'm going to multiply the whole numbers or the coefficients together, and I'm going to add the exponents together of the variable x. Now here, it doesn't say 1x to the third, but I like to think of it as 1x to the third power. So negative 9 times 1 is negative 9. I have x to the fourth combined with x to the third, so it'll be x to the seventh power. Negative 9 times 2 is negative 18, and that'll be x to the sixth, because I have 4 with 2. And finally, negative 9 times negative 7 is positive 63. I have x to the fourth with no additional x's here, so it just stays x to the fourth power. Again, I double check my answer. this expression has three terms. They are all different powers of x, so I cannot combine them. So that is my simplified expression, or simplified answer. So multiply whole numbers, add powers together. Okay. Go ahead and pause the video now. I know it doesn't say you try, but I'd like you to give these two problems a shot, and then hit play when you're ready to see how you did. Okay, so I got -6 and x squared multiplying through here. So -6 times 8. Again, if you need to use the calculator, feel free. It's there for you. It helps avoid silly mistakes. -6 times 11 is -66. I have x squared with no additional x's, so this term will just have x to the second power. I have power 3 and power 2, so that is done. Okay, then here I have a monomial, 8x to the third power, multiplied to a trinomial. So this would be 80x to the fifth minus 40x to the fourth, and then finally 8 times 3, 8 times 3 is 24, and that will remain x to the third power. Double check very quickly. I got powers of 5, 4, and 3, so we're good. Okay. So those are kind of how polynomials are multiplied. Last thing I want to just take a quick look at is what happens if one of the terms or one of the monomials has multiple variables in it. Okay, so if I were to take the monomial -4x to the first, y to the first, I'm going to distribute that with this binomial of 7x minus 4y. Okay, if I do that, I now have -4 times 7. So the coefficient, or the number in front, will be -28. I have x to the first and another x to the first. So that will give me x to the second power. And then this y to the first doesn't have another y to combine with in this first term. Again, we're only focusing on the 7x right now. So I'm just going to bring that y to the first power along. Okay, so there's my first term. Now I'm going to distribute -4xy with the second term in parentheses. So I'm going to focus on this multiplying with this. Okay, so -4 times -4 is going to end up being +16. This x to the first right there doesn't have another x to combine with over here, so it's going to stay x to the first. And then I have y to the first and another y to the first, so I have y squared. Okay, now you do not need to put the powers of 1, so some people will just write it like this. Either way is totally fine. It's understood that these two expressions are saying the exact same thing, just one with the ones drawn in and one without. Okay. So last thing I want to take a look at quick. Again, same idea, but let's see what happens now. Now, this is not a confusing thing, but like a situation that a lot of students struggle with. That negative does not belong to the x squared. That negative is attached to the 1. Okay. Now, the 1 isn't written, but I can draw it in or write it in. So I'm going to be distributing the number -1 and then 2 x's, 2 powers of x and 1 power of y. So when I go here, -1 times 5 is -5. X squared and x to the first is x to the third. And then I have that y all by itself. Okay, so there's my first term. Now here, -1 times 11 is -11. I have 2 x's with no other x's, so this will stay x squared. And then 1 y with 2 y's will make y to the third power. Now, the moment these terms cannot be combined because both the x's and the y's would have to have the same powers. That's clearly not true, so we're good to go with that as our final
Attention
simplified.
support staff, I know that we're in transition of switching our shift. Just remember to continue to check your email.
Go ahead and give this a shot. Give this a you try and pause, and then we'll summarize the lesson.
That has continued to change on a daily basis. Once again, thank you for all of your
Say
work.
hi to Miss Woods. Hi, Miss Woods.
Email for an updated schedule, and please try to enjoy your weekend. Thank you.
I will. Thank you. All right, so 4xy squared times 10x is going to be 40. I have 2 powers of x, one right there, one right there. And then I have y squared that doesn't have any other y's to combine with. And then here, 4 times negative 9 is going to be minus 36. X to the first and no other x's, so that's just x here. And then I have y squared with y to the first, so that will be y to the third power. And this is our answer. Again, it's an expression, but we've simplified it, we've condensed it. Okay. So to summarize, how can I multiply a monomial with a polynomial? Okay, we're still going to use distribution. Use distribution, which, just to remind ourselves, is multiplying. My gosh. Multiplying. Okay. And we are going to multiply the coefficients, or the regular numbers, whatever makes sense to you. If you don't like the word coefficients because it's new and not really sure exactly when to use it and when not to use that word, you can just say, you could say the big numbers. But again, coefficients is the mathematical word, so we'll try to use it as much as we can. And then 3 is we are going to add the exponents. Add the exponents of, as long as those exponents are on the same variable. So both on x, both on y. And that'll do it for the first half. We'll see you shortly.